So here again, what we're going to do is we're going to look at absolute value. And we're going to look at inequalities and equations dealing with absolute value. So it does actually build on what we just did. So first, in order to really understand this, let me define what absolute value is. The definition might be a little weird. So if you have a number, okay, and and you want to know its absolute value, so B represents that number, the absolute value of it, denoted by this, as you can see, okay? By definition, it's given by this. And now, I know this is kind of weird, but all this is saying is the absolute value of B, it's going to be B itself if B is non-negative. And it's going to be negative B if B were negative. This is actually an example of a function, a piecewise defined function. We might see that in the course, but we'll see though. But this is how we're defining it. Now, here I'm just doing an example. If you look at the absolute value of 10, let's say, right? So 10 is basically our x or our b. Well, since 10 itself is non-negative, we're just going to get 10 back. So it gives you back 10. However, if you have -1, right? Well, -1 is negative. So the absolute value of that is -1, which is 1 itself. So essentially all it's doing is absolute value is giving you back the number if the number itself is greater than or equal to 0. But if it's negative, then it returns to you negative that number. Now, I know that's probably a weird way of thinking about it, right? That's probably a strange function, but there's an easier way to think of this. You could think of absolute value as the distance along the number line between that number and 0. So like B, for instance, its distance to 0 is B itself because B is non-negative. And negative B, right? It's also B units from 0, just in the opposite direction. So it's another way to think about it. And thinking about it in terms of distance, it does make things a little bit easier. You'll see what I mean when we get to absolute value equations. But like, for instance, if we had -1, let's say, right? -1 is 1 unit away from 0. I mean, it's to the left of 0, which is why it's negative, but it's still only 1 unit away. So it makes sense that this should be 1. Okay. So that's what we have here. So absolute value is basically distance restricted to the number line. Well, with that said, let's see if we can solve this equation. So what is this equation asking for? We want all numbers whose absolute value is 2, right? Remember, to solve an equation, we want all numbers that you can replace x by and that the equation is true. So we want all numbers whose absolute value is 2. Well, how many numbers are there? Well, we know 2 itself is 2 units from 0, right? Remember, absolute value is distance. So if you think of it in terms of distance, we want all numbers whose distance from 0 is 2. Well, 2 does that, as you can see. But 2 is not the only solution, is it? What if we go to the left 2 units? We get -2. So 2 has absolute value 2. In other words, it's 2 units away from 0. -2 is 2 units away from 0. It's just in the opposite direction. So this is an equation with 2 solutions. You get 2 and -2. Now, Let's really take that a step further. What about this? Well, if you think about it, what is this really saying? We want all numbers whose distance from 0 is less than 2. So we want all numbers that are 2 units, that are, within 2 units from 0, or less than a distance of 2 from 0. Well, is 1 going to satisfy that? Yeah, it is. 1 is less than 2 units from 0. What about -1? That also satisfies it, right? -1 is less than 2 units from 0. Okay? As you can see. In fact, here, if you take anything between -2 and 2, here, let me get the pen out, this will help. If you take any number with it between -2 and 2, that's going to be at most 2 units from 0. Anything that I tried to sketch over. So we're not just going to get 1 or 2 numbers here. We're going to get infinitely many, namely all numbers between -2 and 2 is a solution to this inequality. So everything between -2 and 2 is a solution. In other words, every number in this interval. I mean, in the past, I haven't thought about this as distance. I would give the students an algorithm like, if you see this kind of inequality, do this. If you see this kind of equation, do this. But I'm just trying to get you to understand, what the solutions are when you think about absolute value in terms of distance. Sometimes in math, you have to do that. You have to change or twist your point of view a bit. And then suddenly, oh, it's obvious. That happens sometimes in mathematics. It's mysterious. That was good. Okay, and let me just show this, and we'll go more into this next time because we have about a little less. We have like a minute left. I'll start from here next time. But basically, what I do have is I also have that so-called algorithm for how to solve equations and inequalities involving absolute value. In the past, I've done the absolute value greater than something, but that's pretty complicated, so I'm going to skip that. Not to say you can't handle it. It's really more for time consideration. But this slide we'll start from next time. Okay, let me stop here then.